point. So they made sure that they told you to draw a vector. I have to connect it. In other words, it's moving. It's a moving object. All right. Choose the correct graph. So let's see the one that looks like a graph. It better not be this. It better not be this. It better not be this. That's it. So that's not a big question. It's not a big surprise. All right. Graph the complex number again. Well, whenever the real part and the imaginary part has a negative sign, it's the same thing. They are all in unit in quadrant 3. So the real part and the imaginary part are negative. So they are in quadrant 3. So if this cannot be it, this cannot be it, this cannot be it, because the real part and the imaginary part are negative. Of course, you know that you know how to plot points. So the things that wouldn't waste our time, we're not going to waste time on them. Number 4, graph the complex number as a vector in the complex plane. All right. So we see the standard form of a complex number is a plus bi. We just said that, plus vi. So we're missing a in this. I want to rewrite it so that I have a. So I'm going to write 0 plus, I don't have to write plus, let me just make it negative like it is. Minus 0 minus 3i. So that is the complex number in number 4. I put it in standard form. That way, graphing it, that will not be confusing. All right, so I'm going to make a Cartesian coordinate, and I want to plot the point 0, negative 3. I'm plotting the point, just a point, 0, negative 3. Well, everybody see, x did not move anywhere, but y had to move 3 points down. So this is negative 3. In other words, whenever the real part is a 0, then the vector or the angle formed is a quadrantal angle. Remember our unit 1 unit circle. In fact, if you're told to find the angle, what is the value of theta, you better know that this value of theta is angle in the counterclockwise direction, and that angle we already know is 270 degrees in degree. See, 270 degrees, or 3 pi over 2. Okay, so if you're told to write the complex number in polar form, then what you're going to do is go ahead and find, see, this is the distance, and the absolute value of this distance is 3. And so what you're going to do is 3 parentheses cosine, and cosine of 270. So let's see, this is 0, negative 1. So cosine of 270 is 0. Any point on a unit circle is 0. I mean, any point on a unit circle is cosine theta, sine theta from our unit 1. And cosine theta is 0 here. Okay, so cosine of because this is cosine, all right, and the angle is, so I will just write cosine of 270 degrees, and then here notice that I have sine of 270 degrees also. So we look at the sine, 270 degrees. Sine, remember there's I here, 270 degrees. So the angle, or I can write RC is 270 degrees. RC is the short form of polar equation. All right, so, and the same thing here, let's look at number 5. We first of all graph it. When we graph it, then it is better, we can reason better. So I draw a Cartesian coordinate here. Don't think you already know it and you won't graph it, because if you don't graph it, people make mistakes. I can tell you that. So graph it. And then I want to rewrite. So I'll rewrite the standard form of complex number. So let me just write 4 plus bi. What is b? B is 0. I don't see b. I don't see b. This is easier for me, so I can, when I start graphing it, so I already know that the point is 4, 0. The point I'm going to graph is 4, 0. Okay, and so I will go 4 to the right, 1, 2, 3, 4 to the right. But I'm not moving up at all, because b, the imaginary part, is 0. So this is the point. The point is 4. But if I'm told to graph the complex number as a vector, remember, you must draw a line with an arrowhead. You must draw a line with an arrowhead going from the initial point to the terminal. And if you're told to draw it, now this can be a vector, vector 4, 0. Remember the vector parenthesis. So you have to, okay. Let's move faster. I don't know if you have any question. So answer will better be this. It cannot be this. It cannot be this. It cannot be this. All right. Okay, let's go to the other one. The absolute value or magnitude or modulus. I already told you, when we were in vectors, we call the absolute value the magnitude. Well, right now, vectors are calling it modulus. No matter what they call it, it is the same magnitude, the same radius of a circle, the same radius that you know. All right. So first of all, let me draw a circle. I can make it a unit circle, or I just make it a circle that contains doesn't have to be a unit circle. And I draw a point. And if I complete a right triangle, all right. And remember, we talked about this in unit 1, x, y. And wherever we see x, x is the x component. So I can actually write this x as cos theta, and I can write y as sin theta. So any point, any rotating point, because we're told to write this as a vector, it actually means it's a rotating point. So it's not enough to not put an arrowhead on it. Okay, so where is the theta I'm talking about? The theta is right here. That is the angle formed with the central angle. So the central angle is theta. Okay. Suppose, by the way, let's represent. So this is x, this is y, and suppose this is r, because we don't want to say that this is a unit circle. It can just be any circle, because very soon we get to circle section 8.1. Remember that the x squared plus y squared is equal to r squared. This is the equation of a circle with radius of r. But if I'm looking for r, then I find the square root of both sides. Then I have plus or minus square root of this plus see, so square root and square cancels. And so r is equal to all the time. All the time, r is, in fact, r is the same from complex number section 11.3 to complex coordinate, polar coordinate 11.4 to when you get to the mover theorem 11.5 to polar coordinate, R is the same. So it doesn't really matter how they call it. They call it modulus, they call it absolute value. That should not scare you. Nomenclature or the name of the R should not scare you. Now they call it modulus. So modulus, we know modulus now because it's a complex number in rectangular form. So modulus right now is the same as square root of R squared, the hypotenuse of a right triangle. That's what you need to know. Okay, the absolute value or modulus of a complex number represents the maybe you can call it, I can call it the resultant of the vector. Okay, the vector represented R in the complex plane. So I'm going to call it the result, whatever you call it, resultant, magnitude. Okay, it's not the direction. So the modulus is the same as the magnitude. Modulus is the same as the magnitude. All right, all right. And let's go to question number 7. I don't think I will be following it like this because we need enough time to get to some important things. But if you understand the beginning, don't be in a hurry to finish it all. First of all, if you understand the beginning and can get it all, maybe you miss some of those, some of the hard ones, and you still pass. I mean, not even passing, doing very well. I will try to be gentle, but still, we need to know a lot of things. But okay, number 7. What must be true for a complex number to also be a real number? If a complex number is a real number, let's see the real part. Okay, the imaginary part must be non-zero. No. The imaginary part must, no. The real part must be 0. No. The imaginary part must be 0. Yes. Because if a complex number is also a real number, then the imaginary parts must be 0. If a complex number is a real number, the imaginary parts must be 0. Okay, that we answered that question. I'm not even going to. Number 8, find the resultant. Find the resultant or sum. Okay, resultant and sum are the same of the pair of complex numbers. I want you to know that this is addition. This is addition, okay? So just add them up. Resultant, add them up. Express your answer in rectangular form. All right, do not use a calculator. So resultant is just, let's add it up. The real part, let's call it Z1, is equal to complex number Z1 is equal to 5 minus 6i. Complex number Z2 is negative 2 plus 3i. Then they told me to find the resultant. So Z1 plus Z2. That's what they told me to do. And if I'm doing that, so the real parts of, I'm going to add A1 plus A2. And then I'll add B1 plus B2. And then I put a complex number there. That's all, addition. So let's add it. Let's add okay, so the real part and the real 5 minus, I'm adding 5 minus 2 is 3. So it's 3, that's the sum of the real parts. Imaginary parts of the Z1 is negative 6i plus the imaginary part of Z2 is 3i. So I end up having 3i. So my answer is 3 minus 3i. Okay. Okay. So let's go to number 9. Find the sum of the pair of complex numbers. All right. So I'm going to find the sum. Let's call this sum this time. Okay. They call this the sum this time. So I am going to do this. First of all, write Z1 in standard form. So negative 6 plus 0i. I call Z2, put it in standard form. What I'm writing, you may think I'm taking time, but it helps you. Writing it in standard form helps a lot. 0 plus 4i. And then if I'm going to add them up, I have Z1 plus Z2. If I add them up, I have negative 6 plus 4i. Therefore, the sum is that. Find the sum again. So I'm not doing number 10. I just did it. It's just the same. Find the sum of the pair of complex. You can just add that. Find the modulus. Remember that the modulus is the same as the radius, or the absolute value, the modulus, the resultant, or the radius. Okay, so not resultant, I mean the radius. So I want to find the which one? I'll find the modulus. Okay, this is the one. Find the modulus. So the modulus of this one complex number, if you like, you can graph it. I don't have to graph it. Okay, I can. Let me graph it. I draw a complex plane. I hope you know that this is I. I'm drawing a complex plane. This is negative I. All right, and the complex number Z, I'm going to put Z here, is equal to 8 minus 8i. I just assume that this is these are numbers. So I'm actually graphing a point like this, 8 minus 8. I'm trying to graph a point like this, so you know. All right, if I graph that point, it should be somewhere here. All right, and then I can do not use calculator. So let me do as much as I can. When this is 8 and this is 8. All right, and I just want you to know that the tool does not use calculator. But if you look at that triangle there, it is an isosceles right triangle. Because it's an isosceles right triangle, this is a 45, 45, 90. So the angle here is 45 degrees. In other words, the reference angle is 45 degrees. We can quickly recognize that as a 45, 45, 90. Okay. Well, find the modulus R of the number. So they didn't even ask us to find. Okay, so we're only looking for the modulus. Modulus is equal to square root of 8 squared plus 8 squared. So I have R is equal to, you know what I am. It doesn't matter if I don't put negative here, because negative squared is negative. I can, but it doesn't really matter. And so this is 64 plus 64. They told me not to use calculator, so I have to do what I can. So I have 64 plus 64. In other words, they don't want my answer in decimal. Okay, so I have 8, and this is 128. So R is equal to square root of 128. Let me see if I can factor out. I know that 4 can factors here. So let me go down and factor 128. I can use factor 3. I hope you remember factor 3 from, I remember factor 3 from my elementary school. I haven't forgotten that. So if I start by 2, I can have 64. And if I do here 2 again, so I'm going to be doing 2 until I exhaust all the factors. I don't know if you remember that, but so 2 going to 64 is going to be 32. 2 go into 32 is going to be 16. 2 go into 16. I'm doing factor 3 because they told me not to use calculator. So I'm going to do what I can. And then I do 2 again, I have 4. And I do 2 again, I have 2. So I exhausted the factors. And then remember, it's square root, so I'm going to be pairing them. I have to pair them, so I will factor out. So this is the first pair, 2 comes out of radical sign. Second pair, another 2 comes out. third pair, another 2 comes out. See, I'm doing it because maybe you don't remember. So only 1 2 will remain. Only 1 2 remains in the 2 times 2 times 2 is 8 root 2. They told me to do it without calculator, so I'm trying. So R is equal to 8 root 2 without calculator. Remember, we have been in school for a long time. You can, that's a lot of things you can manipulate algebraically, analytically. You have to show them. You have to really show them. Somebody tests you with something you know, but they told you not to use your calculator. You manipulate whatever it is and get out of it. Okay, so that is number 8. So we found the modulus. Remember that the modulus is absolute value. If you're told not to use calculator, it means you can put your answer in radical form, put an exact answer. Don't forget that. Do not simplify. Don't use decimal. If you use decimal, you're getting yourself in trouble. Even my lab maths knows when if you type in a decimal, when it says the exact form, you lose some points. Okay, let's go to number 12. I want you to remember that this is homework for tonight. Homework 11.4. Very soon we go to 11.5. All right, so find the modulus. Okay, we can do that. I'll find the modulus of, we can do that. Modulus is the same as the radius. You draw by 12, so I don't want to repeat myself. So the same thing, you can sketch but you already know that this modulus is also in the 4th quadrant. It's always good to sketch the vector and then sketch the vector or the complex number, whatever you have to do. And then find, you can also see that this angle is a 12.5. This is you can see that this angle is also a perfect square, 12.5, 12, 13, something like that. But I'm going to let you do number 12. Number 13, find the modulus. Okay. I'm going to start number 13. You finish it. The only hint here is please complete the standard form of a complex number. So don't just start doing it. When you dabble into doing it, you will mix up some things. Even if it means you have to draw a unit circle, draw a unit circle. For them, find the modulus of the number 7. So, first of all, I'm given z is equal to, the real part is given to me. The imaginary part is not, so I'm going to write 0i. In other words, I'm going to plot the point 7, 0. I'm going to plot this point 7, 0. So I make a sketch. And when I make this sketch, I want to go to where the number is. So I have right here, I have 7 go 1, 2, 3, 4, 5. So I have 7 here, and this is the point. There is no, this is my I, this is my negative I. Okay, so there is no Y. And so I can actually calculate R. So calculate R, 7 squared plus 0 squared. So the modulus is R equal to 7 squared is 49, square root of 49 is 7, 0 squared is nothing. And so the calculation of R, the value of R is 7. So it's not a big deal. But that question number 13 is not a big deal. Okay, well, let's go to question number 14. Fine. There's no question number 14. So this is homework for tonight. You can do it. You can do it. If you can do it, then trust me, you can do the test, part of 11.4. Let's go to section 11.5. So now we're going to section 11.5. So we're done with section 11. We're getting there. So I'm going to copy this just in case anybody comes in late. So now we are all going to section 11.5. And I'm going to turn this